Good day everyone. We are the group 5 and we are discussing about energy in the Earth system. I am Luella Kim Alachica and the other two reporters are Madel Briones and Maridel Briones.
Energy in the Earth system. Different fields of Earth science have been studied separately. We have geologists that focuses on Earth's rocks and interior. Another is oceanographers that studied the oceans. Meteorologists studied the atmosphere. But now, combining knowledge of several fields of Earth science in order to study Earth as a system. Earth system science. System, an organized group of related objects or components that interact to create a whole is a system. One of the example of this is the solar system. In solar system, we can see the objects that has closely related to each other. And without the other, the system will not be complete. In solar system, we can see the moon, the sun, the stars, and the planets that interacts with each other. Though the interaction might be complicated, yet if we take out one entity within this group, the interaction would be affected. A large and complex system such as Earth system operates as a result of the combination of smaller interrelated systems as shown in figure number 1. As what you have seen in the picture, there is the organized group of the following. There is plankton, fishes, seaweeds, oxygen, corals, and other marine organisms. If we will take out one from the system, like plankton, which is the main source of food for the fishes, definitely the activity in the system will disorganize and will be affected, thus creating a chaos inside the system. So each entity is vital to form an organized system. Open system. An open system is a system in which both energy and matter are exchanged with the surroundings. The open jar in figure number 2 is an open system. As shown in the picture of an open jar, the matter enters and the other particles inside it, and interacts freely without any interruption coming from the outside and inside forces of the jar. Matter enters like T-bag and the solar energy, and through evaporation, heat exits the system and taking out the T-bag exits the system. A lake is also an open system. Water molecules enter a lake through rainfall and streams. Water exits a lake through streams, evaporation, and absorption by the ground. Sunlight and air exchange heat with the lake. Wind's energy is transferred to the lake as waves. Closed systems. A closed system is a system in which energy but not matter is exchanged with the surroundings. The sealed jar in figure number 3 is a closed system. Energy in the form of light and heat can be exchanged through the jar's sides. But because the jar is sealed, matter cannot exit or enter the system. Provided that is a closed system, matter cannot enter or exit the system. The only thing that enters in the system is the energy in the form of light and it exits through the jar's side. Most aquariums are open system because oxygen and food must be added to them. But some are closed system. Closed system aquariums contain a variety of organisms, plants which produce oxygen, and aquatic animals, some of which are food for others. Some of the animals feed on the plants. Animal waste and organic matter nourish the plants. Only sunlight enters from the surroundings. Earth system. Technically, all systems that make up the Earth system are open, but the Earth system is almost closed as system because matter exchange is limited. Energy enters the system in the form of sunlight and released into space as heat. Only a small amount of dust and rock from space enters the system, and only a fraction of hydrogen atoms in the atmosphere escapes into space. Earth's four spheres. The Earth system is composed of four spheres that are storehouses of all the planet's matter. The atmosphere. The blanket of gases that surrounds Earth's surface is called atmosphere. It is the layer of gases that surrounds the Earth. It's the air that animals and people breathe, and that plants use for photosynthesis. Earth's atmosphere is made up of 78% nitrogen and 21% oxygen. The remaining 1% includes other gases such as argon, carbon dioxide, and helium. The atmosphere protects us from the sun's harmful ultraviolet rays, and it also traps heat from the sun. The hydrosphere. Water covers much Earth's surface, and 97% of this is contained in the salty oceans. The remaining 3% is fresh water. Fresh water can be found in lakes, rivers, and streams, frozen in glaciers and the polar ice sheets, and the underground in soil and bedrock. All of Earth's water makes up the hydrosphere. The third sphere is the geosphere. This sphere includes all of the rock and soil on the surface of the continents and on the ocean floor. The geosphere also includes the solid and molten interior of Earth, which makes up the largest volume of matter in Earth. The geosphere also includes the abiotic parts of soils and the skeletons of animals that may become fossilized over geologic time. The last sphere is the biosphere. The biosphere is composed of all of the forms of life in geosphere, hydrosphere, and atmosphere. The biosphere also contains any organic matter that has not decomposed. Once organic matter has completely decomposed, it becomes a part of the other three spheres. The biosphere extends from the deepest parts of the ocean to the atmosphere a few kilometers above Earth's surface. The third subtopic of energy in the Earth system is the Earth's energy budget. The Earth's energy budget is the balance between the radiant energy that reaches Earth from the Sun and the energy that travels back out into space. There are two main sources of energy in Earth's system. First is the internal sources of energy. Earth's internal was heated by radioactive decay and gravitational contraction. Radioactive decay is a spontaneous process which an isotope, the parent, loses particles from its nucleus to form an isotope of a new element which is the daughter. As the amount of energy as heat generated by radioactive decay has declined, but the decay of radioactive atoms still generates energy to keep Earth's interior hot. Because Earth's interior is warmer than its surface layers, hot materials move forward the surface in a process called convection. And due to the excessive heating and cooling of radioactive decay, this drives the motion in the surface layers of the geosphere that creates mountain ranges, ocean basins, earthquakes, and volcanic eruptions. And the second source of energy in Earth system is the external sources of energy. The sun is the Earth's primary source of external energy. Solar radiation warms energy atmosphere and surface. This heating causes the movement of air masses which generates winds and ocean currents. Remember, the sun external and radioactive decay internal are the two main sources of energy in Earth system.
A cycle is a series of interconnected, ongoing processes that circulate a common component within a system, and it has no end or beginning. The nitrogen cycle, the carbon cycle, the phosphorus cycle, and the water cycle are all examples of Earth system cycles in the Earth system. The nitrogen cycle. Nitrogen is also required by living creatures. Proteins contain a lot of nitrogen. Fixing nitrogen. Approximately 78% of air is nitrogen. From deceased organisms and their waste, decomposers emit nitrogen into the air. Plants, on the other hand, are unable to use these types of nitrogen. Before producers can use nitrogen, it must be combined with other elements. Certain bacteria in the soil are responsible for this. It's referred to as fixing nitrogen. The carbon cycle. Carbon is extremely valuable because of the chemical reactions that occur when it is combined with a variety of other elements. Carbon may be used to make a wide range of different things. Carbon dioxide, for example, is formed when carbon and oxygen combine in the air. Carbon travels through both living and non-living objects in the carbon cycle. Carbon actually has two cycles that are intertwined. The first cycle is primarily biotic, while the second is primarily abiotic. How carbon cycles through living things. Carbon dioxide in the air is used to manufacture food by producers such as plants or algae. Sugar is made by combining carbon dioxide with water. They store the sugar in the form of starch. Carbohydrates are sugar and starch, respectively. When people eat food from producers or other people, they get carbon. The problem with carbon doesn't end there. In a process known as respiration, living beings obtain energy from their food sources by consuming it. Carbon dioxide is reintroduced into the atmosphere as a result. After that, the cycle is repeated. How carbon cycles through non living things. The ground absorbs carbon from organisms that have decomposed. In the soil, some carbon is stored. For millions of years, some carbon might be trapped below. Fossil fuels will result from this. Carbon from the mantle is discharged into the atmosphere when volcanoes erupt. Carbon dioxide is absorbed by producers in order to produce food. The cycle then repeats itself. The carbon cycle is also influenced by the oceans. Carbon dioxide is absorbed by ocean water from the atmosphere. There is 50 times more carbon in the oceans than there is in the atmosphere. Most carbon sinks to the ocean floor, where it can remain for hundreds of years. The phosphorus cycle. Phosphorus is a mineral that circulates through the Earth's crust, water, soil, sediments, and life in a cycle. Rain and weathering cause phosphate ions and other minerals to be released in the atmosphere over time. When a plant or animal dies, the organic phosphate in the soil is reintroduced into the soil. Water in the Earth system is influencing all aspects of life on Earth. Pathways, storage, transfers, and transformations have an effect on the global climate and human welfare. The water cycle shows the continuous movement of water within the Earth and atmosphere. Liquid water evaporates into water vapor, condenses into clouds, and falls back to Earth as rain and snow. Water in various phases circulates through the atmosphere. Our planet is constantly changing. Natural cycles balance and regulate Earth and its atmosphere. Human activities can cause changes to these natural cycles. Humans and Earth system. The natural processes of the Earth and human actions have an impact on and influence on each other. For example, climate has an impact on agricultural productivity, renewable energy potential, and water availability, while human activities such as energy production, industry, and land use changes have an impact on temperature and precipitation.